The concept of a load balancer is that if you have any load on the instance. So what do I mean by load on the instance? Let's say you have to open up a website like google.com. In that case, what will you do is you will actually go and uh, open the IP address. So actually what happens in real life is if I have to go and open google.com, I am actually hitting this particular IP address, which is 172.217.31.206. So if I type that address as it is and I hit enter, I'll see that eventually I end up opening google.com only, which means at the end of the day, whenever I have to hit or I have to open a website, I have to actually go and do that inside my web server, or I have to go and hit a web server or an instance or a IP, whatever you might want to call it. Now the problem with this thing is, assume that 10,000 people are trying to hit that particular IP address at that moment. For example, take example of any of the ticket booking. So multiple people are trying to hit that particular machine at that point of time. Now, if 10,000 people are hitting, the machine might perform. Let's say a million people and hundreds of millions of people are trying to hit that website at that very second. So when I say a website, it actually means they are trying to hit that particular server or that particular instance or that particular service inside that instance. So in this case, the machine gets overwhelmed with the data and the machine is unable to process the request of so many people. In this case, what happens is my server actually goes down, and we understand it by saying that the website is not working or not responding. Or you might even say, for some of you, when it is working, let's say the machine can only take 10,000 transactions a second, and if it is performing to the load of 100%, you will say that the machine is working slow. And the reason why it is slow is because the machine is unable to take that many requests at that particular time. So here the concept is that one IP address is being mapped to one instance, yes. However, if multiple people or multiple connections are made by the same machine, the machine becomes slow. So what is the alternate in this case? Now, alternate now, number one that I have is when I am getting the machine over here. So let's say you are over here, you are hitting that particular IP address over here, which hits a machine, which is a server. Now there are two options. Either you go for vertical scaling. So vertical scaling means that let's say your server initially was 4 CPU and 16 GB RAM. Now if you have more load, you can automatically go and scale up. You can go and make it, let's say, 16 CPU and 32 GB RAM. You have more load, you can make it like 64 CPU and let's say 64 GB of RAM. You have more load, you can make it 128 CPU and let's say 792 GB of RAM. However, in this case, the machine is faster. What if you have more load? In this case, vertical scaling is not going to help you. Also, a problem with this vertical scaling is that you have a single point of failure. This term means that what if that machine, which is having 128 CPU, 792 GB of RAM, completely fails down? Then that's a problem for me because my machine is unable to handle the request. So in this scenario, what I will do is, instead of having one machine or one very big machine, I am going to create multiple smaller machines. Now, please don't confuse this with your auto scaling concept. Auto scaling is creating multiple machines. But right now, what I am doing is all my machines can have different IP addresses. So still at the end of the day, I am hitting multiple machines, but in this case, I want one IP address only. So in this case, the concept that I'll be using will be my load balancer. So what happens inside my load balancer is that someone will be hitting from the outer world. They are hitting a particular IP address, and that IP address is being routed to 3 machines or maybe 4 machines or maybe 10 machines or 20 machines. Or if in case the load is even more, it will actually go and increase it to even more. So in this case, number of machines that are added to that particular magical device, which we call as a load balancer. So a load balancer only job is, let's say, that I have 10 messages which I get and I have three machines. So message number one goes to machine number one, message number two goes to machine number two, message number three goes to machine number three, message number four goes to machine number one, message number five goes to machine number two, message number six goes to machine number three, and so on. In short, what we want to tell is that in this case, the load is distributed equally amongst various servers which are attached to that load balancer at that very moment. So the concept is, I have multiple machines, I have one load balancer, all the machines are getting the traffic at the same time from the load balancer. But if a message has gone to machine 1, that message won't be going to machine 2. That is how the term actually comes into picture, load balancer. This device is balancing the load between various machines. Now, AWS has various modes of load balancer that we are going to see. However, the concept behind the load balancers tend to remain the same. Now, before I go to a load balancer, let's understand a few points about a load balancer first. So point number one, a load balancer, if it has to send the message to three machines or to four machines or to 10 machines, how will the load balancer know in the first place that how many machines are there? So for that, what we do is we go and tell the load balancers that, see load balancer, these are the four machines which actually will be going and responding back to you. So if the four machines are added to the load balancer is going to send the message 1, 2, 3, 4 in an cyclic order to those instances or those machines. First point. Second point, maybe one of those four machines is not responding. In this case, now instead of sending the messages to those four instances, load balancer should send the message to one of the instance, or to, let's say, three of the instances. It should ignore the fourth instance. So how is a load balancer going to know that whether this machine is active in the first place or not? In this case, we use the concept known as a heartbeat. So using a heartbeat, what happens is load balancer will continuously ping the machine every 30 seconds. Are you alive? Are you alive? Are you alive? Or are you active? Are you active? Or are you active? If the machine responds back within 5 seconds saying yes, the machine's health count is increased by 1. If the machine does not respond back, the unhealthy count is increased by 1. So let's say that load balancer hit machine 1 and machine 1 responded back. In this case, machine 1 healthy threshold becomes 1 and machine 1 unhealthy threshold becomes 0. Similarly, load balancer hits machine 2. Machine 2 does not respond back. In this case, machine 2 healthy count becomes 1, unhealthy count becomes 1 and the unhealthy count becomes 0. Now, healthy threshold and healthy health count and unhealth count is done. Now what happens with this health count and unhealth count? So if at any moment your health count becomes more than 10, then finally that machine is added to that particular load balancer. So again, if your health count actually becomes 10, means you have responded to the load balancer 10 consecutive times. In that case, the machine is added to that particular load balancer. And if the machine unhealthy count becomes more than 2, it means consecutively 2 times you haven't responded back to the load balancer, the load balancer removes that machine, which means now the load balancer will only send the message to 1, 2, and 3. Let's say 2 also didn't respond back 4 times. In that case, the load balancer is going to remove 2 and it is only going to send the message to 1 and 3. Now let's say machine 4 actually came back up. The load balancer will not straight away add that machine. It will send the message 10 times to machine 4. Machine 4 has to respond back 10 times. Only after that will the load balancer add that machine to that particular load balancer itself. So remember the words that I told you. First, health threshold, which means if you are responding back, your health threshold becomes 1. Unhealth threshold means if you are not responding back, it becomes 1. Now, if you respond back to me 10 consecutive times, in that case, I add you to the load balancer. If you don't respond back 2 consecutive times, remember the word consecutive, I remove you from the load balancer. And in any case, I will again send the message to you after 30 seconds, which means even though machine 3 is not responding back to me, I will still keep on sending the message to machine 3, asking machine 3 if it is active or not. If the machine 3 is active, in that case, I will wait for the message 10 times. I will still send the message to machine 3 10 times. After it has responded back 10 times, the machine will be deemed as active and it will be added to the load balancer. If it does not, in that case, I will go and make the changes, and then if I want, I can remove that machine from the load balancer. So start with our load balancer. So if I have to create the load balancer, I have to create a load balancer here, and because I want to see it live, what I will do is I'll go and create a web server A, web server V, web server C. So basically I'll just go and create 3 web servers and I will attach it to the load balancer and see how it works. Okay, so let's get started, and what we'll do is we'll straight away create 3 machines over here, and let's make it of T3A, say micro this time. And here I'll go and create 3, or rather let's say 4 instances straight away. Okay, storage 8 GB is fine, this is fine. I have to ensure that the machine is working on HTTP traffic. So I'll just go and enable port number 80 over here anywhere and launch, and I will launch the machines. Okay, so now I should actually have 4 instances which are up and running: instance 1, instance 2, 3, and 4. And click on view instances over here. So I should see 4 instances actually coming up. Let me just go and, because to make it clear, let's go and name it, let's say server hyphen 1, then maybe server hyphen 2, server hyphen 3, and finally let's go and make it server hyphen 4. So now these 4 servers are up and running for me. I'll now go and create the web server or install Apache web server inside them, because if I have to show you, I actually have to make it a web server. And the easiest way to make machine a web server is to install the web server software inside the machine, which is Apache in my case. So let's make a connection with that. For that, I will directly do it this time from the browser only. So here, click on connect. This is my instance 1. Let it be. It has the public IP and the private IP. Okay, so first command, always better to go and do sudo apt-get update, and then we will go and install Apache 2 inside this machine. So let's go now, sudo apt-get install Apache 2. Now, if everything is good over here, it should go and install Apache web server. I'll just wait for one web server to be installed. And the moment it is, we are going to go and do the same thing for all the 3 remaining web servers, so that we ourselves are not confused. So let it work. So Apache 2 web service over here and this one. And now let's go to our instance. Okay, now that everything is done, we can go to our instance over here and we can hit the IP address, this one, on a new tab here, and I should see up some things coming up. So this is indeed my web server actually. And if I have to fix it, what I have to do is I'll just go and make the changes over there. The reason for that is on the top, I see Apache 2 Ubuntu default page. How do I know that it came from server 1 or from server 2? So for that, I'll just go and make a change over here, this one. And instead of title where it says Apache 2 Ubuntu default page, I'll just go and name it something like, let's say server 1. Okay, now if I go and refresh this page, instead of Apache to Ubuntu default page, it should on the top say server -1. So That is how I can know that this actually came from server 1 only. Okay, assume. Now in this case, if I refresh it, I see server -1 over here and I am all good. Fair enough. Now let's go and do the same thing with server -2. For that, I click on the connect button again here, click on connect. And this is my server 2. I'm going to do the same thing inside server 2 also. Please don't be confused about the commands. It's only 2 commands. Sudo apt-get update first of all. And once that is done, sudo apt-get install Apache 2. Then sudo apt-get install Apache 2. And the Y button. Okay, now if everything is done, I will go to my instance over here and I will open the IP address and I'll see that particular IP address, and it should actually have the same data. Then the again same old story, instead of server 1 I will make it server 2. Over here it says Apache 2 default page. Fine, at this moment I will go and make the changes here also. Sudo nano, I'll go for var www html and index.html file, and inside the title I'll just go and make it server -2 over there. X, Y, this. Now, if this is also done, let's go back and refresh the page. On the top, I see server -2. So actually, I have 2 servers up and running, server 1 and 2. Now let's go and do the same for third and fourth also. This time, if you are confused because we are doing the same command so many times, you will actually start to remember it then. Okay, so sudo apt-get update first command. Then once update is done, we go and install Apache 2 here also. Now inside this, one more thing, if I go and do sudo apt-get install Apache 2 here, it will ask me for the permission. Okay, so if I don't want to do that, what I can do is I can just put -y over there. So in this case, it won't ask me that are you sure you want to install, or it will take it won't tell you that it will take this much space and all those things. It will automatically go and install it. So just remember the keyword. If you put -y over there, then it works as it is. Okay, it won't ask for any confirmation. So let's go back to my instance server 3 over here, this particular IP address over here, and paste it. Now again the same old story, it will say over here Apache 2 Ubuntu default page, and let's go and make it here. So let's do that. Fourth server, sudo apt-get install -y and Apache 2, and this should also go and install Apache 2 web server inside my instance. And one final thing that I will do is I will go and make the changes here also, and I should see server 1, server 2, server 3, and finally server 4. So let's just move it here so that we are not confused. So sudo nano var www html and index.html. Okay, now this title over here, let's go and make it to server -4. Okay, now if I go finally, this is all good. Now if I go and go to my IP of server 4 over here, this one, and I hit it over here, I actually see server 4. So I do have one server 1, I have one server -2. Look over here where my mouse is there, server 2. Then one I have server 3, and one I have server 4. Okay, this is just for us to understand that, okay, indeed I am hitting 4 different IP addresses. Now this address server 1, this address server 2, this address 66 52.66.216.232 is server 3, and 15.206.188.209 is server 4. So I have 4 servers up and running, but now we will go and add the concept of load balancer. So assume this is server 1, this is server 2, This is server 3 and I have one more server which is server 4. Now the only job left for me is to create this magical device load balancer, which is going to forward my traffic either to server 1 or to server 2 or to server 3 or to server 4. That is what we intend to do now. So let's get started with that now. So for that, just go to your load balancers over here and click on create load balancer. And you see three examples of load balancer: application load balancer, network load balancer, and a classic load balancer. So you have a CLB, you have a NLB, and you have a ALB. Now ALB and NLB are the keywords that are actually used, so please keep that in mind. So let me give you an example. You just go and type for ALB versus NLB over here, and it will go and tell you. So don't be confused with the words. It is just application load balancer and network load balancer, though you also have something known as ELB. So ELB, elastic load balancing, is a generic word actually. Okay, so if you see over here, select ELB wizard. ELB is a generic word that can mean any of the load balancers. So you actually nowadays what we used is network load balancer and application load balancer. If you happen to work on a front end website more, it is application. If on the back end, then it's network. Elsewise, a classic load balancer, which is for the older networks. So what we'll do, we'll start with the classic and then we will do the other two load balancers also. So fine, let's get started with that. For that, you just have to go and click on create over here. You have to give a name to this load balancer. So let's call it load balancer as website. Okay. And by load balancer protocol and port and instance protocol and port, what does it mean? You see, you are hitting the load balancer at this point. So this itself is a specific protocol and a port. Okay. Second, your load balancer is hitting the machine at the this. So this is a port and protocol. This is a port and protocol. This is a port and protocol. Or in short, this is a port and protocol first, and this is the port and protocol second. So there are two things over there. First is this is known as the load balancer port and protocol, and this is known as the instance port and protocol. So let's go back over here. This I believe you understand. This is the load balancer port, which is on HTTP 80, and then you have the instance port and protocol, so HTTP and 80. So I'm creating this inside my whatever VPC I had, and next I click on security groups, in which one I have selected default. If you want, you can create a new security group, no worries over there. So if you want, you can create it only. Let's call it as a this is a classic CLB hyphen class hyphen one load balancer for CLB done for class, which enables HTTP traffic and HTTPS traffic. So in that case, what I will do, I'll just go and enable HTTP traffic here, in which I will say anywhere, and I'll also go and enable HTTPS traffic, and I will say anywhere here also. Okay, so it will go and enable two traffic over here, HTTP, HTTPS. Next one, it is not having any security because I don't have SSL in over here. I'll tell you what SSL is in approximately 5 minutes. So now, if you remember the story where I told you that the machine has to ping back the load balancer, it has to respond back in 5 seconds over here. The load balancer will again ping the machine after 30 seconds over here. If the machine does not respond back 2 times, it will show up inside unhealthy over here. And if the machine responds back 10 times, then it will show up over here. Right now for testing purpose, because I have to say it up straight away, I'll make it 2 over here, or else I will have to just wait for those many cycles because the instance has to respond back to the load balancer this much times. Okay, 10 times. It becomes a big number. So now next, add EC2 instances. In this case, I can select whatever instances are added to that load balancer. So if you remember, this is what I told that you go and add the machine instance to the load balancer. So this is what you do in the first place over there. Okay, so you just add it. If you remove this, in that case only 3 machines will be added. If you add this, all 4 are added. You don't add anything, nothing is added. But then again, if you add or remove, you are free to go and add a new machine at any point of time, which is the last thing that we will do inside this one. So right now what I will do is I'll just go and add all the 4 machines after one after the other, 1 2 3 4, and next add tags, review and create it. So once my load balancer is all created, if I go and hit my load balancer on this particular DNS name, I should either see 1 2 3 or 4. So let's try that out here, hit enter, and I'll see that it nothing happens as of now. And why it doesn't happen as of now, the reason is, if you remember, we told that a machine has to respond back to the load balancer telling that yes, I am indeed active. That testing or that load balancer is still going on. That you can see from here also, it says 0 of 4 instance in service. If you click on instance, it says out of service, and the reason for that is it says instance registration is still in progress. Now you would understand that what it meant was that it is load balancer is hitting the machine, and the machine is responding back saying that yes, I am active or not. So once it is all good, which should happen in some time, once it is all good, you will actually see that the load balancer is sending the message either to machine 1, machine 2, machine 3, or machine 4 in that order. Okay, so let it happen. So right now it says in service, all the 4 instances are in service over here. Description, if you go, you will see 4 of 4 instances in service, which means now if I go and copy the same thing as it is and place it inside my new tab, first I am seeing server 3. So first it has hit this machine. Now if I go and refresh it once, I see server 2. Now if I refresh it, I see server 3. 4, 1, 2, 3, 4, 1, 2, 3, 4. So if you see, if you just have a look over here, this part, okay, I'll keep on pressing the refresh button. 2, then again server 3, then again server 4, then again server 1, then server 2, then server 3, then server 4. So this is what we wanted to do, that we are hitting the load balancer, and the load balancer is hitting the instances at those specific whatever you have given in that order. So 1, 2, 3, 4, or whatever that order load balancer thinks it is fine. So actually now what happens is, instead of hitting the instances directly, instead of you hitting the instance directly, you are actually hitting the load balancer, which is in turn is hitting either 1 or 2 or 3 or 4. Okay, so if you keep on refreshing, you will see the same thing, 1, 2, 3, 4. Now you might have a question, what if I go and add another instance over here, and let's call that instance as server hyphen 5. Okay, so let's try that out right now. So here and Ubuntu 20, we will do this very fast now. So let's go for a, let's say T3A small. Okay, let's go for a medium only, and then straight away security group. And let's go also and enable port number 80 because it has to work on HTTP traffic. So launch this and launch the instance. So this particular instance at this particular time, I'm just going to name it by server hyphen 5 over here. So let's try that out. Server hyphen 5. Okay, now this machine, first of all, so you will have to go and configure your server 5 to be a web server. So for that, again, the same old story, you go make a connection, sudo apt-get update, and then go and install it. So let's do that, make the changes on top of it and all those things which we have done earlier also. So first thing, sudo apt-get update. And once it is done, sudo apt-get install -y and Apache to here. Now it will go and install Apache, and the final step will be to go and change the file name over there. So we will go and make it server hyphen 5. Okay, let it happen. Now let's go and make a change. Sudo nano, which is the text editor, var www html and index.html. And let's go and make the change to the title over here, and let's call it something as server hyphen 5. Okay, now which means that if you close this instance also, and if I go back to my server 5 now over here and I hit this particular IP address, I am going to see that yes, it is indeed telling me server hyphen 5. Okay, let it happen. Okay, strange, it didn't happen. Let's have a look. Because the security group wasn't added. So let's go and add that port number, or you can make it HTTP over here and anywhere and save rules. And now if you go and hit this particular IP address, it should respond back with server-5 over here. So I do have the 5th server, but if I refresh it, I still see 1, 2, 3, 4 only. And the reason for that is this instance you have created fine. You also have to go and add that instance to your load balancer over here. So for that, you go to load balancer and you click on instances and you see 4 instances are there. Click on edit instance now and just add the 5th instance also and click on save. Now just doing that isn't going to add your instance because right now it will say instance registration is still in progress. That's the same thing which you saw some time back, where in that case it was actually doing the same thing for those 4 instances. So in approximately 30 seconds, you are going to see that this instance 5 will also actually come up, in which case you can do a refresh between instance 1, instance 2, instance 3, instance 4, and instance 5. Okay, so let it actually come up right now. So let's just refresh it. And it is indeed active, which means now if I go to my load balancer over here, my DNS name, which is this, and I hit this and hit enter, I see server 1, refresh 5, refresh 2, 3, 4, 1, 5, 2, 3, 4, 1, 5, 2, 4, 3. It's like that basically. Okay. So in this case, what happens is 15342, 15342, 15342. It's like that basically. So now my 5th machine is also added to the load balancer. So this is how you can go and add the machines to the load balancer. Or just so if we go back and we see, click over here, we will see that all the 5 servers are indeed responding back. Okay, 1, 2, 3, 4, 5. Now by the same logic, if you go and stop any of the instances right now, you will see that the load balancer will automatically understand and it is going to remove that instance from that load balancer. Okay, so this basically is our example of the classic load balancer. So now let's go back to our next load balancer, and that we will be taking a network load balancer. So concept remains the same again also here also, in which case what will happen is we create a network load balancer. Now a network load balancer is required when you have or need ultra high performance, also when you have to handle million of requests per second securely while maintaining very low latency. In that case, you go for a NLP or a network load balancer. For that, again, it's the same thing. You just click on create over here, and in this case, you will have to go and give a name to this load balancer. So let's say, let's call it like web server hyphen NLB. And this is facing the internet. Like in this case, it is facing the internet. No, so just keep that in mind. So it is facing, if you have an internal one, you can do that also. So internet facing, now it can be for IPv4 and IPv6, both. If you want dual stack, right now I'm just taking IPv4, which is inside my VPC over here. And I can choose whatever instances or whatever subnets I have to enable. So I'm enabling it in 1A and 1C. Also, if anyone is hitting me on port number 80, if you remember in the previous one, we had directly given the IP addresses, so or the instances we gave directly. In this case, in case of a NLP, what happens is that we create something known as a target group. Target group is almost the same as that, only in this case what happens is you go and add the instances straight away. So let's test it out right now. Let's call it web server, or let's call it Apache web server, and my Apache web server, which is working on port number 80. Same health check if you want, that is fine. This is inside my VPC. Next step, you will go and add the instances. Now the same thing over here. In this case, you are going and adding all the 5 instances, and you are just going and adding a target group to it. So remember, in case of this, you will have to go and get this Apache web server target group. So let's go back to our NLB, in which case, if you see, you won't see that. The reason is you have to refresh it once because you have created that here. So refresh it, and here you will now start to see Apache web server. In that case, again, you just have to go and click on create load balancer, and it should all be done at this point of time. So that's it. Now what will happen is you can go to your NLB over here, load balancer or web server, with whichever you want, web server, this one. Click here and paste it over here, and you will see it again doesn't open up. And the reason you would have understood by now, because the load balancer is still doing the registration of those machines. So we will just wait in for approximately 2.5 minutes, after which this load balancer will be active. And how will I know? By looking into the state, it says provisioning right now. That is how I know that yes, this load balancer is actually still provisioning those machines. Now, if you want to see another way, classic load balancer, let's have a look. While this is still provisioning, we will go to a classic load balancer and see a few things. If I need to add a instance, I can do it from here. Similar way, if I want to remove an instance, I can do that also. If I click on save over here, these instances will be removed then. Okay, let's see the example. If I click on save over here, you see other two instances are gone now. So if you go and hit those machines now, you will see that the request is not forwarded to those instances. So I see server 243, 243, 243. Just have a look at this part over here. Okay, this part here. Server 2, server 4, 3, 2, 4, 3. It's in that order only. And the reason you understand, because I have removed the machine. Now, if you want to add, you can click on edit and you can add that. So now I should see 1, 2, 3, 4, 5. However, it won't happen immediately because again, the health check has to be passed. Fine. So that's your edit instances part. Apart from that, if you want, you see the health check over there. Timeout is 5 seconds. I expect the response within 30 seconds and so on. Apart from that, you have your listeners, which is your port number 80 of load balancer is hitting your instance on port number 80. That's also a thing. Then you have your monitoring, like your cloud watch, in which case you can see the latency. Latency is just how much time it is taking for you to send the response back. That is your latency. So you do see some latency. In ideal cases, you understand latency should be as low as possible. You can see the healthy instances. Initially it was 4, then it went back to 4.7 because at this time I had added one more instance, so it went to 5 over here. Okay, similarly the unhealthy also you can see, because nothing was unhealthy only at any point, so it becomes 0. In ideal scenarios, this should always be 0 only, because if it is up, it means that your instance was not responding to the load balancer. Apart from that, you can see the error. If any error came, http 4x error, these things, and all these things are visible to you. Okay, so we do see monitoring, we saw tags, we understand. Migration you will only see in case of a classic load balancer, and the reason for that is classic load balancer is actually a pretty old load balancer. So if you want, you can directly migrate it by clicking on ALB migration wizard, and you just have to click on create, and you will see that automatically the application load balancer is created out of it. So you see, now have a look over here. This load balancer over here happens to be a classic load balancer. This load balancer is an application load, a network load balancer, and the third one which we migrated is application load balancer. So we actually have 3 load balancers at this very moment. Now, by the way, when we had tried to open this, it had given me an error. Let's go and try the same thing out again. If I refresh the page, I should see actually this coming up. Now, in ideal cases, you will see that it is still pointing to 1 only, and the concept behind this is something known as stickiness. Stickiness in general word means that if I am hitting the load balancer and I am being forwarded to instance 1, then if I hit the load balancer again during some duration, I'll still be forwarded to machine 1 only. So this concept is known as stickiness, often seen in your network load balancers. So that's the reason why I am being forwarded to 1. However, if you wait for some time and you refresh the page, you will see that you will be forwarded to a different server. Now in real life, what happens is, here I have put server 1 2 3 4 5. In real life, it will all be the same servers only. Okay, so from your perspective, you don't even know that whether you are going to instance 1 or you are going to instance 5, because for you all the servers are the same. And that anyhow is the concept on which load balancers actually operate, that a load balancer has to send the request to multiple servers at real time. Which server it is going, it should not even bother you, and you should not even care about which server it is actually going in the first place. It's going to 1 2 3 4 5 or whatever it is. At the end of the day, you are being forwarded to a server, and that's more than enough. Okay, so that's the concept of a load balancer. Now if I go to server 2, if I refresh it again, you will see that I am forwarded to the new one, server 4. If I wait for some time, click on refresh again I will see the new one. So that's your network load balancer for you. Now, by the way, my application load balancer is still into provisioning state. I can click on refresh and it says active. in which case I can go for the DNS name here also for my application load balancer and hit enter, in which case I will see I am being forwarded again to a different thing. Okay, so this is server 2 application load balancer. It works like your CLB or a classic load balancer. So as many time as you hit enter, you will see new servers only over there. Okay, so stickiness is not there inside your application load balancer. It's there inside your NLB or network load balancer. So if you keep on refreshing it, you will see the sequence is 14532. So 14532, it's in that order, 14532, and it will continuously show you 14532 only. I believe you understand. You have to look over here, and if you press the refresh button, you are actually going there. Now my NLB is server 4. After some time, if I press, I will see different one, which right now is server 3. And now if I keep on pressing the refresh button, I will still see server 3 only, until I wait for some time and I press the refresh button again over here. So that's the concept of load balancers. Now, one last thing over here, you see something as a target group also. Target group we had anyhow created also, if you remember. So if I go to my Apache web server and if I want to go, so the same concept, that inside my classic load balancer, if I have to go and add an instance or remove an instance, so in real life, what I will do, I will click on edit instance and I can remove it from here. Okay. However, this does not happen in case of a application load balancer or a network load balancer. You cannot directly go and change the things. In this case, what you do is you go and make the changes inside the target group. Okay, so for instance, this network load balancer over here, go to listeners, it says that you have to go to this target group. You go over there, you click on targets over there, and then if you want, you can remove them as many as you want. Just click on deregister and it will remove those instances. Okay, you will see them draining and then they will be removed basically. Now if you want to add them again, no worries, click over there, it will start showing you the instance. You can click there and you can add them. So the same way as you removed them, you can add them also. So in this case, again, it goes into initial state and that's it. Now the same thing, if I have to go for my application load balancer, here I have my listeners, which is going to my this particular target group, which is my website target group. In that case, again, the same concept. I can click on target over there. I can click on register or deregister target as I want. If I click on deregister, then they are gone. So that's the concept behind your load balancers. And these are the load balancers which you see: a network load balancer, a classic load balancer, and an application load balancer. Let's go back to our classical load balancer. Now inside my classical load balancer, what I can do, I can directly go and add the instances to my load balancer itself. Okay, so I can directly do it from here only. Now, however, in case of my network load balancer and application load balancer, I directly don't go and add it to my instance, or I don't add my instances to the load balancer. Rather, what I do is I forward them to whatever target group I want to give them. Advantage of this is, assume this scenario wherein you can have multiple load balancers and all of them have to forward to one particular instance only. Now, let's say I have 10 instances and I have 10 load balancers, and all the 10 load balancers are forwarding to my 10 instance. Now, if I have to remove instance 8 from those 10 load balancers, in case of a classic load balancer, I will have to do that operation 10 times because I have to go and do it manually one by one. Same thing if I have to do inside a network or application, the smart approach I take is I directly go to my target group and I will remove it from there only. Doing that will ensure that whichever load balancer is hitting that particular target group, that particular load balancer itself isn't having the machine, which means there I had to do 10 operations, here I have to do only one operation. Take another example. Because of heavy load, instead of 10 instances, I have to go and add 5 more instances. So 5 more instances means I have to go and give 5 things over there. So basically 5. How many operations I have to do? 10 operations in which I have to go and make the changes 5 things. Okay, 10 operations. Same thing inside my target group, I would have just gone and added to my target group over there, in which case I am only doing one operation. So target group, if you want to understand, it is like your IAM group where you just go and add that thing once and it is automatically propagated to each and every one of them. Now, one last thing over here, if you want to see, in this case, what happens is inside my Mumbai region, actually, I see three load balancers, which is my network load balancer, application load balancer, and my classic load balancer. However, inside my North Virginia region, I have one more load balancer type, which is something known as a gateway load balancer. So let it just load up. Over here, if I click on create load balancer, I will also see a gateway load balancer. Okay, so this load balancer is when you have to go for third party virtual appliances over there. So in that case, this load balancer is going to work on IPv4, and you can go and create now in whatever way you want. So let's say, let's give it a name, gateway load balancer 1. Configure routing. In this case, again, the same concept. You can go and give your target group over here. But remember, this is for the external ports or external protocols. Okay, you can give that. Let's say this is a gateway load balancer hyphen target hyphen group hyphen 1. And next you go and give your targets over here, which can be on that specific IPs, whatever the range of IPs are. So this is a new type of a load balancer that isn't there in Mumbai as of now, but it is there in North Virginia. So you might see it in few 4 to 6 months from now. You might see this load balancer inside your EC2, inside your Mumbai also. So these are the three load balancers. Deleting them is as simple as just go select the load balancer, actions, click on delete, and the load balancer is gone. So similarly, this one. Okay, you can also delete multiple in one shot itself if you want. This one, and if the load balancers are gone, it does not mean that my instances are also gone. Instances are separate thing. Load balancers are separate thing. It's just that instances are added to the load balancer, and that's pretty much it. Okay, so I have my 5 servers, which I'll just go and terminate them here. And this is about my EC2 instances and load balancers.